Oh, thank you. Well, welcome to this very much improvised beginning of a webinar this time, and this almost Christmas break. So thanks for joining. You know that we are all rushing. Today I'm actually super happy because I have the chance to present something that me and my colleagues here have been working for a while, and I think we are very passionate about it. So we are really amazed that so many people showed interest in it. Is a reciprocating friction test. Straight to the point, we have here, I go in order as I see them in the screen. Dirk Spalman from the Federal Research Institute in Materials in Berlin. If you want to say something about a couple of words or well.
My name is Dirk Spalman. I'm working at BAM for the last 25 years. Currently, I'm the acting head of the Tribology group at BAM. BAM is a federal institute with responsibility to the Ministry of Economy and Climate Action. And my background is studying physics in Aachen and Cardiff. I was working for 3 years in a startup company, and then I joined BAM, and since then I'm damaging everything I get in my fingers, if it's steel or ceramics or coatings. And I learned it's called Tribology, and during the last 5 years I'm cooperating with Mirko, Inigo and Javier. And I learned that I have to do it the proper way, and that's why we're here in this group trying to adjust, or better saying harmonize our procedures. And from that I hand over to the next one. Who's next on your screen, Javier?
I got Mirko Krell from same institute.
Well, thank you. Yeah, also from the Federal Research Institute for Material Research and Testing in Berlin. I joined BAM, which is the German abbreviation BAM, in 2020, right at the beginning of Corona, for the project TriboNet, which has become a company now. The CEO Xavier, with the CEO. My background is I'm a chemical engineer. I worked in industry for a couple of years, developing polymer materials for bearings in that sense. And then I joined BAM to get more into the details of tribology, and I learned a lot. And I was wondering a lot, and that's one of the reasons why Xavier, Inigo, and Dirk and I got together for reciprocating friction tests, which is quite an important topic, I think. And I got to learn at BAM that there are some things open, and we try to close those gaps, let's see. In that sense, enough from me. So the next one, I don't know, Xavier, would be Inigo, right? Probably.
Yeah, you are good.
Good afternoon, everyone. My name is Inigo Jabori. I come from Monan University, where I worked in the last 15 years here, almost 15 years. I work primarily in fatigue and tribology problems. From the perspective of numerical simulations and also experimental, so I got the best of both worlds. I hope that I can share some of my experience with you.
Oh, thank you. Thanks for the presentation. And here we also have Manoj and Ida and me as come on, we are always here. Sorry, you are so muted, Ida.
Sorry. Hello, everybody. That's what I said.
Hi, guys. Yeah. So I guess I will just jump in if everyone is ready. I mean, this time we wanted to do a bit more of a debate, a discussion, because we know it's a topic that I want to share something funny. Yesterday we met up, all of us, and there were only 12 people registered in this webinar. So we thought, okay, no one cares about it. Let's cancel it. You know, like this standardization, this reciprocating, it's totally useless. And today I either checked again and it was 153. So I don't know what happened, or there was a mistake from our side, but I'm extremely happy to see the interest on this topic. So thanks for being here. So, I spent the whole night thinking, like, man, are we wasting our time here? Apparently not. Cool. So next slide, please. It's an interactive debate, so I think that this time we want to do something different. So whenever you want to interrupt, raise your hand, and either Manoj will take care of it. If you participate, or depending on the questions, yeah, we'll try to make it as dynamic as possible. It's almost Christmas. Yeah. Oh, my part is short, promise. Maybe because I spent too long in Luleå and I did all these skiing things. I always wondered about the friction coefficient between the skins, the skins of the skis when you do ski touring and the snow. The idea is that friction in one direction is completely different than the friction on the other direction. So, and I always wonder what happened is that I take the ski skin and the snow and I put it down a tribometer. What will the tribometer tell me? Because, I was very fascinated. No one cares about the direction of the motion, of the movement. And from there, I start pulling and say, whoa, there's a lot of things that we give for granted and they should not. And that's more or less the motivation. Then, from a practical point of view, the whole point here is about why is Tribology so irreproducible? I practice that. Not reproducible. So the idea is that we, many times, if we are not extremely careful, we have a lot of spread, a lot of huge variation in our results. We conducted round-robin tests among different institutes, different labs. We really find it's very lab-dependent and even operator-dependent. So what are we missing? So why is it so difficult to get the same results? So are there too many variables, or are variables that we cannot control? Are we imprecise? I mean, sensor-wise, are the sensors not good enough? I was last week in a particle accelerator. It's amazing what they do there. They are extremely precise. Like, why cannot we do or that the same in tribology? Procedures. It's like every lab is doing different procedure. Are they one's measured in one way, the other one's in a different way, and that is why we think that the results are not comparable. And ultimately, samples. Yeah, so, tribology is a system of materials, but what about the materials? Are the samples the same? Are they all of the samples flat? Porosities, hardnesses? Can we control all these variables? So yeah, I think everyone here, presenters, I would say part of the audience is concerned about that. Like, why cannot we go to a table of tribology friction coefficients or wear rates? We need to test again and again and again. And yeah, we are just trying to to help a little bit on the topic and see if we can figure out. And just to finish my part, can you click twice? I didn't know this was animated. So really quick, in a practical sense, we set up a platform and try to bundle tribology labs, and we have a database. And being very practical, labs send the results to the database. And yeah, surprise, surprise, we have differences. The same test in different lab, they give different results. So yeah, that is not fun in the database. We managed to narrow down, so let's say by best practices, testing and repeating, we could narrow down the results, but it took us actually 2 years. Yeah, I'm afraid that we need to do that for all the tribological tests. So that's all from my side. The pain is like, what are we trying to attain, tackle, or how we can contribute to make tribology more reliable. Thank you.
Okay, so I will continue with the academic perspective, at least from my side. Okay, this is not the whole academic perspective, but it's some discussion I have with my colleagues and something that I think we think that are quite important. regarding what Xavier said. So would you click one more time? So if we go to the best books of tribology we can find in the literature, here we have some of the landmark books that are quite important in tribology. Obviously, these works are amazing. These works are the foundation that we have in tribology. You can see there that we have lots and lots of citation of this book. So if you can click one more time, please. However, if we go to see what these books tell us about the topic of today, which is how to calculate or how to compute the friction coefficient or how to perform these tests. Interestingly, methods and techniques for calculating these coefficients of friction are not often extensively covered in these foundational books. So I guess that there are living room for further exploration. So if we can go to these books, only at least I found 3 pages regarding how to calculate the friction coefficient. So I guess that we have much work to do in this aspect. So if we go to the next slide, some interaction with the audience. I guess the question is, during your tribology courses, if you have any at the university, do you learn about alternative methods for calculating the coefficient of friction besides the typical formula of friction force divided by normal force and look at the maximum value of that friction curve? So if you can raise your hands, please, if we can count.
Funny because you see the order as well, so you see who's faster. The fastest was Amaya Misra. So
I guess 4, 5, 6. So okay, at least 60% of the audience did not learn about this topic, which is somehow a number that we will see later on. So yeah. Obviously, there are alternative methods to calculate the friction coefficient. This method is not the best method, let's say, to calculate in some occasions. So, let's talk or let's discuss about this. So if we go to the next slide here, I will tell you my story about tribology and how I learned about it. So I learned about tribology during my PhD, which was supervised by Dr. Xavier Gomez. So I had a unique opportunity to gain a comprehensive understanding of tribology, which I designed and manufactured a tribometer. I did experiments, and I did also the numerical. I developed a numerical tool that will predict the tribo fatigue behavior of cables. Especially of thin steel wires that compose the whole cable. So in this sense, I used finite element method to design the tribometer, and then I used also the numerical study to correlate what was happening during the tests. So in the right-hand side, you can see some friction loops there, and I was able to correlate very well how the friction loop changed during the test. So I had first a kind of flat-topped, friction loop, but then because of where this shaped or this non-cooling behavior appeared, which you can see the hook-like shape at the end of the stroke. So I learned a lot during this period of my life, which I enjoyed a lot. It was really an eye-opening to learn about these things. So, yeah, this was my story. So if you can click, well, yeah. So what happened during this friction and wear testing? And in the upper side of the figure, you can see different friction loops that I recorded during different cycles. So at the start of the cycle, you can see that you have a kind of flat-topped friction loop, but then during the test, this loop distorted a lot. So you can see that distortion is quite high. And then I calculated the friction coefficient, and you can see that with different methods, I obtained huge differences. Okay, I talked with my colleagues and with my PhD advisor, and the differences were very large, up to what 200%. So, I mean, if you have these differences with these methods to calculate friction coefficient, I mean, I can give you any number. So if I can give you any number, which is the number that we are looking for. So there is no standard regarding this. There is nothing, or at least a few papers I could find that talked about these things. So, and so at least from my point of view, 3 eye-opening articles that I recommend for friction calculation I have here. There are more, okay, but at least from my perspective, these are the 3 papers that I learned a lot, which the first one is from BAM from the early 2000s, and then I understood the importance of energy, how to calculate the friction energy during the cycle and how to obtain the friction coefficient from that point of view. Then I understood the behavior of the distortion of these loops were because you had the effect of wear scar shape, which changed a lot. And depending on how these wear scar is, you have massive differences. And in the bottom paper, I learned a lot about how the machine stiffness changes the behavior of these loops, and the combination between these 3 papers. I mean, I could explain a lot of what was happening during my tests. So if you go to the next slide, I have a couple of friction loops, and if you can click, you can click up to, So essentially, these are some examples of the friction loops that you can find in the literature. Okay, and there are more, but here we have some of them. So depending on which friction method you use, which method that you use to calculate the friction coefficient, you will obtain different things. So, I mean, so what we can do here? That's the question. So yeah, and then one of the byproducts of my PhD was that well, let's talk about this and let's write a review paper of which methods that we can find in the literature and what people do. So one thing that we do, we read around 100 papers, and we did some statistics here. So we could find that 41% of the papers did not report the friction coefficient method. So they were saying that this is the friction coefficient and that's it. So and then from this, almost 60% of the reported data, if you can click one more time. So 51% of the reported methods were used the least effective method, at least from this kind of fretting phenomena, let's say. So now the question was, okay, so 41% of the paper did not report the friction coefficient method, and 51% of the methods of the papers report the least effective method. We have a huge number of papers that we cannot trust really. So click one more time. Essentially, at least 70% of the papers, there are questions regarding whether the calculation were done correctly or not. So I mean, these are huge numbers. So yeah. If we go to the next slide, and just to finalize my talk. So at least we can at least the impact of our work, which I think people liked. And we analyzed only for 2024, and a couple of papers, not 200 papers, but I think I analyzed like 30 or 40 papers. So again, it's the same number repeats. 60% of the papers reported how they calculated the friction coefficient. But at least in this case, 67% of the papers used the energy coefficient of friction methods, which, in my opinion, is best suited method for this kind of problems. So yeah, that's it from my side. I don't know if anyone wants to comment something or to add something.
Yeah, I think there was a question from Fred. Fred, you can ask it yourself. You can turn on the camera, and you also can just ask the question. Or if anybody else has the question, you can unmute yourself and then ask.
Yes, I have a question. Can I put my question? Hello,
Yes,
good
sure.
morning. Hello, everyone. I'm Milka Ramalho from the University of Coimbra. And I have a question for you because you talked about a specific case, fretting.
Yes.
And in fretting is not exactly the same that's talking about reciprocating in general. Because you said that, okay, the friction that we measure depends on the method or in the method to calculate it or the method to measure. But in fact, in several cases in fretting, we cannot speak about friction coefficient. Why? Especially when you have not a real sliding involve the surface, we don't reach the maximum value of friction coefficient, and so the concept is not applied.
Yeah, but I was talking about fretting wear, which is a cross-sliding phenomena.
But you show several cases where where we have a partial slipping in some of the loops, and in that case,
in all the cases that I show, it was cross-sliding.
No,
so we go back to the slide, please.
One it's an elliptical, should be a partial slip case. The second one in the bottom part should be the second one from the left. This should be a partial slip, and in that case we cannot speak about
You're right.
about friction coefficient. This is one case. In the other case,
sorry, Amilcar, just a second, because this slide is mine. It's good to see you. This slide is mine. I put it inside. It was to show that even if there's no full slip.
But you have a reason. You have a reason because this case could be a gross slip with a very big compliance in the reading system. So there are a lot of problems behind fretting. I suppose that fretting should be treated as a different way, because it's not the same as another thing is what is fretting in general. What is the limit? 300 of microns. This is not good.
But we are talking about one case that I have. But I mean. In all these cases, you could find a lot of different cases, even with, let's say, with different material, polymer to metal contact, and then you have the stiffness of the material, and you have this kind of compliance of during the test also. So, I mean, this is not only for fretting cases. This happens in all cases.
Okay.
But you could have different friction loops, and this slide is to cover different friction loops that you could find. So depending on the method that you use, you will obtain different results, and that's the problem. That's the problem.
But I agree with you. But for me, fretting is a different thing, and I agree with you that in that case the energetic approach is the best. But what is the limit of the fretting? The fretting should be defined by an energetic way. Sorry. Let me finish just 1 minute. Fretting should be also limited energetically. We have fretting when the energy dissipate, the density of energy dissipated and butt of the contacts are in same order of magnitude. This is the unique way to limit fretting. And we should start to have very, very good definitions. Otherwise, we cannot start to build nothing. And in tribology, we don't have a good basis to start to build nothing. Okay, but this is my opinion. Sorry.
I cannot agree more. Thanks for coming, Amika.
Yeah.
Yeah, we all agree there. We need to start calling things by their name. And I like a lot the definition of fretting that you mentioned. I mean, we should start writing this down. And as you said, tribology is underdeveloped when it comes to harmonization and standardization. Thank you. I love it. This is a debate, so it is very welcome. Please, anyone, American again, please join in.
Yes, hi. Is my microphone working now? This is Fred.
Hello, Fred. Yes, we can hear you. Yes.
Okay, good. Sorry, it took me a while. I couldn't unmute my microphone for some reason. My background is physics. I have no experience in tribology, but I appreciate the effort to harmonize this. And so I was wondering, on that data, number of cycles, does that plateau at some point, and would that give a hint as to, what's the fundamental problem here, or whether it just takes more cycles to harmonize?
Yeah. So if you go to the previous slide, Mirko. Yeah, for example, here, if you use in the graph that you have in the bottom side, in the left-hand side. So if you use the maximum friction coefficient, the friction coefficient is increasing, and it didn't stop at any time. But with other methods, you have a kind of plateau value. So in this special case, the wear scale during the test changed during this test. So the friction was changing, in each cycle. So it was a difficult case. But I mean, if you can see the energy coefficient of friction or geometric independent coefficient of friction values, they are kind of stable across all tests. I mean, there are some changes with the energy coefficient of friction, but that is because the slip amplitude changes a lot also. So, but I guess that at least in my point of view, the friction coefficient, if during this analysis, it didn't change a lot. Depending on the method, you can have different results, but yeah, and that's the issue. If you have something like this, depending on the method, you will reach different conclusions. So I don't know.
So from a physical point of view, every time you slide, there's also wear.
Yeah.
Nothing is stationary. Yeah. That's a very good question.
Okay, just to follow that up, out of ignorance, I think of the viscometers that I've used and the different techniques for measuring viscosity, and I wonder if that's considered a part of tribology, or can we learn anything from their various techniques and maybe extrapolate something?
Yeah, sure. I'm not an expert with let's say lubrication, but yeah, I think I believe that there are a lot of work here also to develop in that sense.
To complement that reply, yes, we normally distinguish between dry and lubricated tests. So you guys are now showing dry tests, but we do, of course, lubricated. So tribology system. So we don't talk about materials, but systems of materials. I don't know if that helped, but yeah, we do a lot of rheology, viscosity, or characterization of lubricants. Definitely. And if the oil is degrading or the properties of the oil are changing in time, that could also change the friction. I think America had hand raised again. No? I don't know.
I mean, at least now, no hand.
Okay.
Sorry,
maybe you can continue.
Oh, yeah.
Yeah.
Thank you very much, guys.
Guys, I have a question. So somebody's microphone is not working, and the question is, could you please be more specific and explain how the methods of measurement work? I'm only used with mean coefficient of friction, which I have used during all my short career so far. The question is from Damien Abreu, if I say it correctly.
So, for example, in the let's say that you have the picture that I have in the left-hand side, in the upper side. So if you take the maximum friction coefficient, you will have a really large value. Let's say in the cycle 150K. So if you take the peak value, you have a tangential load that is 4 newtons. So if you and in this test, I don't remember if it was applied 2 newtons. Yes, I think it was. The contact force was 2 newtons. So in that case, the friction coefficient, if you take the maximum friction, the maximum force, the friction coefficient is 2, because you are taking the maximum value. So the second one is the mean value of the friction coefficient. You take all the tangential load values and you average them in an absolute terms, let's say, just to take into account the negative and the positive part. And in that sense, you have a mean value, but the velocity of the reciprocating test is important in that case, because we have to remember that the sampling rate it's constant it's constant. So maybe, for example, you have 200 points per cycle. In the streams where the velocity is lower, you accumulate a lot of points there, and in that case the values might be really low. So in the averaging process, those values, they average it down. So the mean value, just to take the average of all values, is not a good approach, because you are integrating in time, which is not good. Then the next one is the energy coefficient of friction, which in essence you have to calculate the dissipated energy, the area in that graph, and then you divide by the normal force and here it is the key, the slip distance. Okay, the displacement, the applied displacement, and the slip distance are not the same. Okay, because of the compliance of the contact system. So in the case that you have a really large compliance, then the values of the energy coefficient of friction can change a lot. So that's the third one. And the fourth one is the geometric independent coefficient of friction, which is kind of difficult to say how they calculate it, but essentially you take into account the compliance of the contact system, and then you calculate where is the midpoint, exactly the midpoint the midpoint of the test. And in that point, the vectors of the friction force and what measures the sensor are aligned. So in that sense, you are calculating exactly which is the friction coefficient, because both vectors are aligned. The problem I encounter with that method is that the method is very sensitive to the noise, so you have to be very careful. But essentially, there are the 4 methods I know. You have more information in our paper, which is in our slide, but I think it was quite a long answer. Sorry for that.
I would suggest to write a publication in TriboNet, if you don't mind, with a format or well explained with examples. I think that even me, I would love to see that.
Yeah.
Because to me it's not that, it's a bit confusing as it is now. Thank you, Inigo.
Yeah.
Please continue, guys, then, I think.
Yeah.
Can I comment just about the effect of the compliance? In fact, there are an alternative method, is to measure the compliance in both of the directions, calculating the average value, and after deducting and correct the relative displacement using the value of the compliance. This is what I do, and just after I calculate the energy dissipated by friction. In my opinion, is the best way, is to measuring exactly in the system what the compliance is, correcting the value, because it's a linear equation, correcting indirectly the values of the relative displacement, and just after calculating in my opinion, it's the best method.
Thank you. That's super.
I agree. For the majority of cases, it's the best method for sure.
Cool. Now we need to wonder why there's no standard in it, no? But I think Mirko will mention about. We'll continue on that part. But it's amazing that we all have different, come from different parts, but we agree that the best method is one. And that's really a very good beginning. Sorry, Mirko.
Yeah,
it's yours.
Thank you very much for the nice discussions we have so far. This is very good. So I try to hurry a little bit because the hour is ending soon, sooner or later. So the question, I mean, there are also more than 4 methods that Inigo just showed us, as we just heard. That there are other approaches, and there are even more mentioned in some standards, which is my topic I'd like to talk about today. Because we already talked about that harmonization is missing, and why is it missing? Because there are so many methods, and if we are talking about harmonization, we are also talking about standards. And this is an issue because, well, first of all, I think standards, I will just say some words here, they are important. Why we do standardization? I mean, we can all agree that standards are a good thing to have. I mean, no screw would work compatible with another screw or head if there is no standard for that. So it's about I need to practice that word. They need to be compatible. They need to be comparable. It's about knowledge transfer. I mean, every academic improvement could also get a standard and then applied by industry, because standards are also used by industry if they are good. And also standards would help us to create trust along also trust among us. I mean, if I say I use that method mentioned in that standard, then someone else can be very sure that it's the right thing because the standard is good. So we are comparable to one another. And also we are thinking about, let's say, digitalization. So data, as Xavi just said, we have a database in our Tribomat. The data inside needs to be, let's say, comparable, that one person evaluating hysteresis or friction loop is doing the same thing as another person, and when they get together in the database, that they are the quality features of those data are sufficient enough to work with them. For example, for machine learning, artificial intelligence, all those big data things, we actually need big data and they need to be comparable. But as there's always a but, also in the standardization, there are some buts. They need to be kept up to date. I mean, the technology and knowledge is improving, is advancing, and also the standards need to reflect them. They need to address the current needs to be accepted and used. If they are old and not updated anymore, then no one will use them. And at the end, standards are always a joint effort. I mean, standards are created by many people, and so you need a consensus in some way. And for that consensus, you need at least some people involved, that you get a good picture how people are doing things, and then create a standard out of that. So my question for the audience right now, just to get a first impression, if you have some friction loops and need to evaluate them, do you use any standards like ISO standards, ASTM, or any national standards to evaluate those friction loops and to calculate the coefficient of friction? Just raise your hand if you do so. Okay, 5 seconds passed. No one is raising his hand.
Is there such a standard? I'm wondering.
Well, yeah, I will shortly come to that. But at least I was hoping, but at least some people raised their hand. That no one is raising their hand. This is a kind of a surprise for me, but also very good because it shows us that there's. Okay, now we get some hands here. Inigo is using a standard.
Yes, that's Inigo.
But no one. Okay, Patrick. Hi, Patrick, by the way. So very few people. And yes, the question in the chat, I just thought, are there actually standards that define the methodology? This is an issue, and this I will say some words about it in a few seconds. So anyways, we see now here that no one, or nearly no one, is using any standards to evaluate friction loops. And this is exactly the point why I want to put this on the agenda. What's the issue then? Because on the one hand, we have standards for reciprocating friction tests. They are for metals, they are for polymers, they are for ceramics, for lubricants, for bearings. And the issue is here, same as tribology, they are scattered everywhere. So you have different technical committees, you have different working groups working with reciprocating tests, and they all create, to the best of their knowledge, some standards to evaluate friction loops. The thing is, if, let's say, many people think about the same thing but not talking to each other, they may come to different conclusions, which is good because they do it the best as they can, but it doesn't necessarily mean that they come to the same conclusion. So this is an issue that the existing standards insufficiently describe actually how to calculate the coefficient of friction of friction loops. And at the same time, the existing standards, some of them are, let's say, a little bit older, let's say 20 years or something like that. And in between, the hardware and also our understanding of tribology has improved. So that means that we have new approaches, or we see new things that we didn't see so far, and the standards do not reflect them. And another issue is that without those standards to calculate, or a uniform, a harmonized standard, how to calculate the coefficient of friction loops, what should the tribometer manufacturers do? Of course, they do also the same thing. They do it to the best of their knowledge, but it doesn't mean that the tribometer manufacturers actually come to the same conclusion, which means that the tribometers are not comparable. We are comparing apple and pears because there is no standard. And I just see in the chat that there are some comments like G99, for example, ASTM. I will come to my next slide then and just say some things about the existing standard, at least to my knowledge. And the thing is that the standards existing for reciprocating friction tests, they do not really go into very details. Like Inigo just told us, there are, in most standards, there are no formulas at all how to calculate the coefficient of friction. They just say how to say it. For example, the ASTM D6425 for lubricants, it just says the peak value. Is it the maximum coefficient of friction or is it not? I do not know. And the thing is, we have no clear definition what is the maximum coefficient of friction or what the peak value is. And at the same time, the ISO 19291, which is basically the same setup as the ASTM 6425. I will stop saying all those numbers. You can all read them. They define the same test for lubricants, but the ISO standards tells us to use the peak-to-peak method. What is the peak-to-peak method? Is it the same as the peak value? I don't think so. And as this sketch on the right-hand side shows us, the maximum coefficient of friction is not necessarily the peak-to-peak coefficient of friction. So And the main question I see it in the chat, what's behind all of the methods? What is really the friction, coefficient of friction? Yes, very good question. So anyways, coming to an end to this, there is no standard available at all, at least to my knowledge, that clearly and unequivocally defines the calculation of the coefficient of friction for friction loops. So this is an issue. But it's a low-hanging fruit. As Inigo just told us, there are publications available that could help us here and make this into a standard. So because no one knows all standards, I'm also the one. I saw in this chat that there was writing someone about 1894. Yes, plastic films, correct. And the 4518, I didn't know that. I will write that down right away. And everybody else can unmute or use the chat as well if you know any standard that clearly defines the coefficient of friction from friction loops. Okay, we have the 4518 ASTM. Yes, and the 1894. Okay, no one is activating his or her microphone.
Hi.
So,
yeah, shall I ask a question?
You can also go ahead and ask questions.
Yeah, perfect. So I think it's a very good question about identifying standards in order to calculate COF. I think Professor Milker has already put a question, what is friction coefficient with respect to, what, as in definition. So when we are looking into different applications, say, for example, biotribology and things like that, how are we going to obtain a standard there? Because as per the application, friction definition itself changes and the system changes. And then since friction is a system property, how are we going to obtain a standard? Or is that even a right question what we are asking?
But I think I had a similar say, impression, but I think we are trying to standardize the calculation method, right? But not the, let's say, testing conditions, materials, or whatever, because that is very difficult, I assume.
This is exactly the point. Thank you. The thing is, sorry. What I wanted to show is just the calculation method of a coefficient of friction. Like, for example, those standards I wrote down here, like for example, G99, which I missed here. Sorry for that. This is for plastics, I think, and also the 133 is coming from a technical committee dealing with polymer testing. And they're giving just let's say a description how to calculate the coefficient of friction, but it's for the calculation out of the loop of the friction loop from the, let's say, sensory data is, from my point of thinking, independent of if I use a polymer, a metal, or what else. You just need all the, let's say, procedures that there are, and then you select the one which you would like to choose for your system. If it's a metal, it's a polymer, it's a ceramic, I don't know. But you need, from my point of view, a clear definition how to do that. Not to do the test. I mean, this is very application specific and material specific, but the calculation of the coefficient of friction, from my point of view, could be uniform, irrespective of the, let's say, materials involved.
Can I join the comment or an idea about that? I have a lot of experience on that kind of things. I worked in Tribology for around 40 years. And I developed a lot of methods to measure, to test them. In my opinion, we never measure friction force. We measure an equilibrium force of the system. And the relationship between the friction force and the force that we measure are a second-order system. And in some cases, there are a linear relationship between the measuring force and the friction forces, but not in the other cases. This is valid for unidirectional sliding, but especially for reciprocating sliding. So in my opinion, we never measure friction. Another different thing is the question that I said, what is really the friction coefficient? And we should analyze the basis. We should read the Théorie des machines simples, Charles Coulomb. And there we can see that and this is the physical approach of the friction, is a linear relationship between two forces. And so it's a slope. And if we agree that is a system dependent, depends on the operator, depends on the test system, depends on the laboratory, of course, the problem that we have is a systematic error. And we cannot solve the systematic error just using statistics. We have to establish something. We should consider that the friction coefficient should be applied if we have a linear relationship between tangential force and normal force. So we have to verify if we have, in the nice system that we have, if we have or not a linear system. This is one question. And after, if we have a linear system, we should calculate the friction force as slope. I recommend to you to read something, because always this discussion, it's a very old discussion. The scatter in tribology, it's big, it is not possible to obtain reliable values and so on. But I recommend you, as standard, to read and to see the standard for fatigue, ASTM E739, about statistical treatment to obtain the linear relationship to obtain the CEN curves. And there you have exactly how many specimens you have to test, how many repetitions you have to do. Because today, when we want to publish something, the guy asks, how many repetitions you did? This is a very bad way to solve the problem. I have to change the normal forces or the sliding distances in order to obtain reliable values. Another paper that I recommend for you is the Ashard papers of the 90s, but the Ashard papers really. And you can see that that guy, in the first paper, in order to calculate two wear rates, one for brass and the other for scalit, he did almost 100 of tests for each material in different conditions, of course, not repetitions. Why? Because he needs to verify if there are really linear relationships behind. But we've forgotten the basis. And the basis to the definition should be Charles-Coulomb law and the physical approach. The friction coefficient, it's a linear relationship between two forces. It is not possible calculating a slope just by a single point, even if we did 10 repetitions. And this is what the error of our approach, in my opinion. The other case is because we never measure the friction force. It's very dependent on the relationship on this second-order system.
Yes.
And concerning the standards, in order to have reliable results, we should apply MEMS in our equipments, accelerometers, 3-axis accelerometers. It's very cheap today. It's enough to have good, the values with the sensitivity that we need. Why? To reject values when we reach very, very high acceleration values, because in that case we never have reliable results. But this is my opinion after a long way.
Well, thank you. I mean, I do not disagree in any sense. The thing is, I can only add to that. You said this is a very old discussion. Yes, it is. I mean, I started at BAM 4 years ago, but I know that, for example, in the BAMAS project in the end of the 80s, there was also round-robin tests done. And I know that. The thing is, we're talking about a very old discussion. And from my point of view, being, let's say, 4 years in tribology, I'm asking myself, if it's such an old discussion, why hasn't anything changed? We are still discussing about the same things, and there's nothing to. And from my point of view, standardization might help if people get together and discuss those things in detail and then come to a conclusion, consensus, and then find a way. And another thing is, Inigo showed what you said about the, let's say, the friction force is not necessarily the tangential force or the sensor force we are measuring. It is totally right. Inigo showed this in his paper, but the equipment, the tribometer, often just measures the, let's say, horizontal force, neglecting the wear scar, for example. So you get a signal, and this friction loop, the signal needs to be processed in any way to get a coefficient of friction. And this is, for example, where I think standardization can help to do that calculation, because there is none at the moment. So, okay, Mark, you raised your hands. Mark, go ahead.
Yeah, sure. The slide that's on the screen there, I've been partly responsible for some of the input into a couple of those documents, so I have to put my hand up and say yes, we didn't specify things that exactly. One of the things that bugs me about this discussion, though, is that it seems to be asking, can we produce a number to describe such a complex phenomena? And I don't think that's actually possible. So you've got a complex friction loop, and actually there's a wealth of information buried in that loop. So what about things like static friction coefficient, dynamic friction coefficient? What do they mean? Do we need to take a step back and look at some of the fundamentals of what we're talking about? There's the discussion that Amilcar raised about the dynamics of the test system, and actually that's extremely complicated, because you've got three different axes for two different bodies that you have to consider in terms of test dynamics, so it gets exceedingly complicated. How do we find a route through this? The other thing I'd like to say is that common reciprocating test, where the speed is changing throughout the loop, you've also got the effect of speed coming into it. So do we need a raft of definitions, not just one? Thank you.
Thank you, Mark. I mean, perfect question. I mean, we have four methods, let's say, that Inigo proposed, right? There are more, if you look in literature, for example, and also in your report, Mark, in this 11811, there's also mentioned this window method, let's say, where you put just 50%, for example, from the hysteresis in the middle. So the question would be, more than just one number, the coefficient of friction? Why not? I mean, we can say that if we do a test, we have multiple coefficients of frictions in, let's say in quotation marks, that we have more than just one number to evaluate the system, because we are discussing a system. So maybe the outcome of some standard in the future could be you need at least 4 coefficients of friction to describe the friction out of these loops sufficiently. I do not know. The future will show us. But it's a good discussion. So I don't know. There are more hands raised. We are already at 4 o'clock. I do not know how to proceed. What is your thinking?
I think I think Ahmed is going to ask a question.
Who is that? Hi. Thanks for allowing me to ask.
Welcome.
Thanks for allowing me to ask the question. My question is slightly different. All these innovations and all, like for coefficient of friction or any other standards, I feel they are what I call lagging in time. Like you want to do something today, by the time the research is done or by the time the people get involved, that particular thing is already, gone, or we have suffered, let's say. So there should be a strategy of research, or from ASTM or all these standardization committees, that they should have a very quick thing. Like maybe it's the team or the group or whatever way you call it, or more people should join that group where research is done. Like I am in lubrication side only, around 43 years experience. Now I want to give back to the community what community has given to me. I'm available for research or anything voluntarily. because it's our duty after so much of experience or gaining from the what's called from the world or from our colleagues to give back to the thing. So there should be a quick thing, like we are discussing this thing today, but the problem exists and it will keep existing till. That's sorry. Go ahead.
Well, thank you for the question. Thank you for the question. I mean, then. Sorry, Xavier?
No, I was just going to say, I love this. Please reschedule another meeting. I love it. I need to go. And Mirko is the right person to answer that question. So.
Okay.
Okay. So we go ahead, right, with the session. Anyways, perfect question, because this is exactly the let's say, introduction or the bridge to this slide. Your standardization goes into two directions, right? You need to put something in and you get something out. And the idea is to get standardization and also Sensenelec kind of identify this as an issue, that you have some time lag between, let's say, the issue and the standard at the end. And one solution they propose is the CEN Workshop Agreement, which is a pre-standard, which usually takes half a year until it's finished. And half a year is much faster than a standard, because a standard usually, let's say, 3 years you need to create a standard. And this CEN Workshop Agreement, CWAs, were created, I think, in 2020 or something, so they're rather new. But this is an approach to accelerate standardization and to get, let's say, this pre-standard. It needs to be evaluated 3 years after it has been firstly published, but then it's finished, and the idea is to bridge the gap, let's say, to first create a CWA, that you have the first document where this workshop, where this group of people, and it is not, let's say, connected to any working groups or technical committees. Everybody can join, even people that are not into standardization, and come together and discuss things. And at the end, you create a CWA, a document everybody agreed on, and this could be a first thing as a standard. And we are planning to do a CWA based on the outcomes of the Tribology challenge. You know, we gather data, how people are calculating coefficient of frictions, and at the end we will use that data to create a document where to standardize this. That's the first approach. We do not know when to start. It will be 2025, 2026. Take some, let's say, time to prepare these things. But I think this is enough to answer your your question. You're perfectly right. Standardization needs to accelerate.
Thank you very much, Pro.
You're welcome.
Yeah, I think we've got lots of points and lots of discussion that has happened on this topic, and we do have lots of people who wants to participate. We can just continue for more than 10 minutes. However, when we get into this topic where there's a lot of, like when Professor Amilcar was saying, this is a historical topic where people starts debating and questioning about lots of things rather than getting into one point of conclusion where we are going. So this kind of deviates from what topic we initially started and where we are going right now, because our initial point was, where are we heading with respect to standardization? Are we able to standardize the friction calculation and things? And rather we started discussing more on friction experiments and what is coefficient of friction and things. I think we should come back to our initial question again, saying that, is there a proper way to standardize, and does this challenge bring us into such conclusion, and how can the participants help in doing that? Do you guys want to ask or request something from the participants maybe in order to, standardize?
Well, what we are asking from the participants is A, take part in the Tribology challenge to provide your insights and providing data how to do that, and all those things that you use to calculate friction loops or the coefficient of friction will be, let's say, considered at the end. And at the end, everybody here is very welcome to join, for example, this CWA, so that there is, let's say, a conclusion out of the data, that there is a next step, that we end those, 30, 40 years discussion, and we all come together and create a standard. However it will look like, I do not know, but this is exactly the idea behind standardization, to get things started. We have some more slides. I mean, yeah, this is something, right? Does standardization help us? As I said, it goes into two directions. Would you help to standardize, right? We cannot standardize without people getting involved. So I will end with that, because there are some more slides. Well, Xavier left now. because we wanted to present some things about the tribology challenge now.
Yeah, there's a question from Fred. Yeah.
Yeah, a quick comment. I dealt with a very respected test facility a few years ago to measure insertion and extraction force of a connector, a custom connector. And one of you mentioned the difference between standardizing measurements and standardizing the facilities. They were actually getting very unreliable data, random data, and it turned out their actuator was not linear. They thought it was a consistent travel, but it was actually must be driven by a stepper motor. It was actually moving in steps, micron steps, so it looked very continuous. And so, and people assumed it was because it was a linear actuator. So the test facility, can throw everything off. And if they're not standardized at the fundamentals, then they're not going to be standardized on the measurements. Thank you.
Good point. I mean, this is tribometer as part of the system. So the result you get is depending on all the tribometer parts, which is also the actuator. So, I mean, there's also a standard missing how to actually build a tribometer. What sensors to take, what design to take. There are standards that define, let's say, material tests, but not how to build a tribometer. So, of course, the tribometer does not necessarily work on the same principles, and that's why it provides different outcomes. But this is something we do not want to touch in the first part of the tribology challenge. We want to focus on the data evaluation. And then let's start somewhere, and somewhere would be the first step to actually come to the data evaluation, the calculation of friction. So, yeah, how to continue? I do not know. We are now over 4. Do we continue with the tribology challenge without Xavi? I mean, Dirk and I can say some things about that also, or do we set up another meeting? I don't know. What do you think from TriboNet?
You can just say quickly if you have something to share, but we will organize something separately later on as well. Yeah.
Okay. Yeah, maybe with some more time to discuss things. Anyway, Dirk, I will say some things about the first part of the tribology challenge, then I will give to you to your part, right? Is that okay with you?
Yeah, fine with me.
Okay, very quick. We have 19 people so far answered questions regarding our tribology challenge. I'm sorry. The idea behind that is, as we said in the beginning, to actually have consequences of the work to make our results comparable, and start with the friction calculation, or not the friction calculation, but the calculation out of the loop you get from the signals, and to stop reinventing the wheel. I mean, there's many testing methods outside existing, but I think it would be helpful to get and standard, as I said. And part of that, let's say, challenge is the part A, the data evaluation out of friction loops, or data loops, as we just discussed, that you get a CSV file and you do your calculations method with that CSV file. And then you get a questionnaire where you answer those things, and then we collect all the answers and then try to get let's say, first of all, see what standards are outside, and then the other what range of results we get just from 4 loops, right? It's not much, but it's enough to get different results, as Inigo showed. The part B, which will start, I don't know when, maybe 2026 or something, we'll be actually doing experimental round-robin tests worldwide, as done many times before, sending samples around, putting them into your tribometer, and then testing the system and see what comes out. And maybe already using the same calculation method, which we have done in part A. So this would be the idea of the tribology challenge. Part A is still open. The deadline is extended to the end of January, so you still have time to join and have a look, do your things, and provide, let's say, insights into your methods. So yeah, just one quick thing. What's the coefficient of friction? We discussed this. This is something discussed before, that you get some data, you get some signals out of the tribometer. You can put them into the, let's say, displacement domain. You get a friction loop or hysteresis, and then you evaluate things. So you get a coefficient of friction out of the loop, and you put them into a diagram over cycles, and then you get those, let's say, diagrams, which might become stationary depending on the coefficient of friction, as or the method how to calculate the COF, as Inigo showed. And then you do some repetitions, and you get some curves. So the idea would be to gather the approaches out there to, let's say, evaluate this, to evaluate the data. How do you do that, right? Okay, so the first part is open. This is dealing with 4 friction loops, I think, and then it comes to the calculation, I think. And with that, I give to Dirk, because I think this diagram is something you would like to say something about, right?
Yes, but it's not the one which I had prepared. But okay, never mind. It already shows the results. Left-hand part, we were carrying out round-robin tests among the 5 tribological institutions that are currently supporting the European Tribology Center. And for that, it was a major aspect to produce comparable data independently of in what country the institution is located, independently of who is operating the tribometers, and whether you use in-house built ones or commercially available ones. And Ram was sending around 100 CR6 balls and discs. And nothing wrong with standards. They're a good point to start with. And I was asking all technical institutions to test according to standard, and they got the same parameter sets, and the result is shown on the left-hand side. The average there is of each operator, and each operator was carrying out several tests on the same sample. And the red lines mark the 95% interval, and left-hand side is when you get it asked according to standard, and everyone was using different or interpreting standard differently, sometimes not knowing what kind of coefficient of friction was coming out of the machines. And when you start to harmonize and not comparing apple and pears, yes, they are all fruits, but they are different, then you come up with an entirely different result, which is the one on the right-hand side. And compared to where we got off with, it was already nice, but the question was, can we still improve on that? If you click 1 time, please. Okay. Yeah, carry on. Now, at the starters, we're also asking the question if we characterize our samples properly. And the first thing which I try to avoid is, if you order grade 10 balls, which are currently standard, you get them in the bag. And due to transport, you shake them, you rock them, whatever. And if you look at one of such samples, click again, please, and I hope it can be seen. There are cracks on them, there are indents, there are scratches on them, and there are also material transfer. Click again, please. So, can you produce similar results? Can you expect that depending on what is now the actual contacting part of the ball? And another thing that rattled my mind when I was dealing with trying to get comparable data, in 2020 we were investigating a roughness standard, which is traced back to Germany's National Metrological Institute. And we were investigating this surface with 4 different methods, 2 tactile ones, 2 optical ones. And for the optical ones, we were using different lenses, and we were producing the same set of Z values with different types of software packages. And yeah, the results marked in orange are out of range. The roughness or friction is happening at the surface. So the surface is very important, because depending on how you run in your samples, you have a different steady state if you get one. So if you ask someone to prepare a certain roughness value, and he's using different types of evaluation software, different type of machine to analyze it, the result should be independent of the machine or method you're using. So I was very surprised that you get such results that a lot of values are out of range, especially if it comes down to surface roughness. I think, hit the next button, preparing proper samples will be a huge issue for part B, but Mirko, I think part A is still going on, which gives me a bit more chance to improve on methods for part B.
Exactly. So as written on the left-hand side, part A, and I said before, is still open, still running. We have 19 replies so far, so which is, from my point of view, very good, because this is like say 19 opinions, and we know that those 19 replies, let's say, contain many opinions. 4 experts, 5 opinions in that sense. So we'll also get that in the Tribology challenge, which is good, because this will all be basis for the future things to come, for example, the CWA. So the deadline for this first system A, test A, which is part of the first part A, is extended to the end of January, so you can still join. Go to the website, Tribology challenge. You have it on the right upper side of the slide. You can download the questionnaire, you can download the CSV file, and then send to Xavier as a PDF. And your input is very welcome. You had a lot of discussions today. You can also discuss things in the document in the questionnaire, right? So ask questions or answer questions. We don't mind. And that's basically it from my point of view. I hope everybody could follow. We are 17 minutes beyond schedule. Some supporters of the Tribology challenge, I think some well-known competent centers in Tribology here from all over Europe. And feel free to join. And that's kind of the last thing to say before saying happy holidays. Or I do not want to end anything because I'm not the host here. So I give back to TriboNet. Sorry.
Yeah, thank you. So I also posted the link to the Tribology challenge in the chat. So I hope everybody can follow and join the effort. I think the discussion today was very, let's say, very live, and it also, from one hand side, it shows the importance of the topic. On the other hand, it shows the differences in the opinion, and I hope this is going to work, because I have been working also in Tribology for quite some time, and for me, all these questions are also there. I think this initiative is, I hope it's going to come to some solution. With that, I would like to, with that, I would like to thank you, the presenters. It was fantastic. Thank you. Thank everybody for joining. Thanks for the questions and the discussions. I think this was one of the most interactive sessions we ever had. And I see, Mirko, you prepared your hat already, so you are very into the Christmas already. So I wish everybody happy holidays, Merry Christmas, and good achievements in the coming year. And see you, everybody. See you all later.
Thank you very much. Thank you for the discussion. And
thank you, Either. Thank you, guys.
Thank you very much.
See you.
Thank you.
Thank you. Bye-bye.
Bye-bye.